All right, the quiz review for Unit 2, okay, sections 2.1 to 2.3. All right, it says directions first always. Underline the hypothesis and circle the conclusion. So remember, hypothesis follows if, and conclusion follows then. Now, that doesn't mean there's always going to be an if and then, okay? It may be a similar idea, different structure, but that's the basics. So if you like the ocean, well, you like the ocean. Then you're a good swimmer. There's your conclusion. All right? So hypothesis, conclusion. If, so as soon as we see if, it is raining outside, then it is cold. Hypothesis, conclusion. Now, for example, 3 and 4, here are ones that are not written as an if-then, okay, that we can change to an if-then. All children must attend school. Okay, so basically, if you are a child, then you must attend school. Right? So it doesn't ask you to do this, but we're going to do it for practice anyway. Here's my hypothesis following if, and here is my conclusion following then. Congruent angles have equal angle measures. Right? So we'll take the first part. If angles are congruent, then they have equal angle measures. I just use symbols to save space. That's the word measures. Work with me here. All right. So again, we didn't have to do it, but I'm going to just for practice. Here's following my if, so that's my hypothesis. And then my conclusion is following then. All right. Write each statement in words, then decide if it's true or false. So let P be an animal is a puppy, and let Q be it is a dog. So P, then Q. So if an animal is a puppy, then it is a dog. So my P is animal is a puppy. Okay. So that's my hypothesis. Then it's a dog. Is that true or false? Well, it's true. A puppy is a little dog. Now, you might think of pups for other animals. There are other animals that the babies are called pups, but not specifically puppies. All right? So that is your answer. Now, again, if you said false and you could justify it, like say, well, baby seals are called pups. I'd probably give you credit for it, but generally, puppy refers to a dog, so that's true. Now, the converse. So the converse, we just switch them. So it says if Q, then P. So you would say, whoa, don't know what's happening there. There we go. If an animal is a dog, then it is a puppy. Now, all we did is we switched them. So before it's puppy then dog, now it's dog then puppy. So now if we look at if an animal is a dog is our hypothesis. Again, you don't have to do the underlining. I'm just doing to reinforce it. It is a puppy. Well, if you have an adult dog, it's not a puppy. So this is one of those ones that can be true, but as a general rule, is false. Because it's not always true. All right, the inverse. So the inverse is where we take the original one right here, and we're just going to add not, that's what the tilde means, to both of them. So we're going to rewrite the first one, if an animal is puppy, except we're going to say if an animal is not, now you don't have to write it all caps like that, I'm just stressing it. If an animal is not a puppy, then it is not a dog. Now, this is a tricky one. You might think, well, that makes sense. If it's not a puppy, okay, then it's not going to be a dog. But remember, a dog is an adult dog. It's not a puppy. So a dog is not a puppy anymore, but it's still a dog. Okay, so even though it sounds right, okay, that if an animal is not a puppy, it's not a dog, it's going to be false. Because one counterexample would be a dog is not a puppy, but a dog is definitely a dog. All right? And then the contrapositive. So this time we're taking be and just adding not to it. So we're switching them and then negating them both. So we look at be, or we're going to rewrite that basically. If an animal is a dog, except we're going to say not. So if an animal is not a dog, then it is not a puppy. And again, all we're doing is we're taking be and adding not to both things. So if an animal is not a dog, okay, then it is not a puppy. So let's think about that one. Okay, so not a dog, not a puppy. Does that make sense? Well, that one's going to end up being true. So let's think about it. If it's not a dog, you might go, well, what if it's a puppy? Well, a puppy is a dog. It's a younger dog. So that doesn't work. If it's not a dog, let's say a cat, well, then it's not a puppy. If it's not a dog, horse, not a puppy. So that would be true. All right, moving on. Done with those. Decide whether the statement about the diagram is true. Explain your answer. Angle 1, which is right here, and angle 2, which is right here. Okay, I use different arc length number for different measurements. Add up to 90. True or false? Well, that is true because we have the 90-degree symbol. If we did not have that symbol there, we could not say, well, yeah, it looks like it's 90, because as we've seen before, it could be 89.5 or 90.1, but not 90. So having the symbol there allows us to know it's they add up to 90. So what are they? Complementary. All right, AC, which is this piece right here, is equal to CE, this piece right here. All right. Do we know it's true or not? Well, we don't know. Okay. We cannot assume. Okay. Now, the way we would know is if we had hash marks like so. Then we would know that those segments are congruent. But without any given markings, we cannot assume. They may be, but we can't tell that. Number 8, rewrite the definition of the term as a biconditional statement. Remember, biconditional means if and only if. Okay? Obtuse angles are angles with measures greater than 90 and less than 180. Okay? So, you can say an angle is obtuse. I'm just using symbols there to save space. An angle is obtuse, and then we put in our famous phrase, if and only if, and we're just going to write the rest of it pretty much. It measures greater than 90 and less than 180 degrees. Okay? Number 9, if the negation of a statement is true, does that mean that the original statement is automatically false? Right, so that's going to be true. Right? And the reason is the negation is the opposite. Right? So if your statement is true, the negation is true, the opposite of true is false. All right? Moving on. Describe the pattern, then write the next two numbers. Okay. So this is just usually a guess and check. You have to, unless you see the pattern automatically. Like number 11, I see the pattern right away without having to use any logic to figure it out. But everybody's different. Number 10, I don't see the pattern right away. So I need to try some things. Okay. So this is where you do some guessing and checking. So from 2 to 5, I'm adding 3. And then I'm adding 6. And then from 11 to 23, now you might think, oh, 3, 6, 9. Well, 9 plus 11 is 20, so that's not it. So 3, 6, from 11 to 23 is 12. And then 47 minus 23 is plus 24. So 3, basically times 2, times 2, times 2. So times 2 would be plus 48, and times 2 would be plus 96. So now I just need to add 47 plus 48 and get 95. And then if I add 95 plus 96, I get 191. Okay, another way you might see it is, and it just came to me, 2 plus 1 is 3, so I add 3. 5 plus 1 is 6, so I add 6. 11 plus 1 is 12, I add 12. 23 plus 1 is 24, I add 24. 47 plus 1 is 48, and so on. So there's more than one way to describe the pattern sometimes. The latter one came to me kind of quickly. So I have the first letter of the alphabet, then the last. Second to last. Third to last would be X. Fourth to last, what comes before X? and that would be W. And yes, I just had to say the ABCs in my head because I can't say them backwards. Oh, actually, I could have stopped at that because we only needed 2 letters. So, oh well, got a bonus. Make a test and conjecture about the given quantity. The difference of any 2 even integers. Okay, so what do you think that's going to be? All right, kind of get in your head what you think it might be, and then let's test it. So make a test, conjecture about this. So the difference of any 2 even integers. So I'm going to put a bunch of minuses here and do it a few times and see what we come up with and try different things. So 2 minus 4, those are both even integers, is -2. 4 minus 2, let's just flip it, equals +2. 6 minus -2, well, that would become plus, so that's 8. 30, -30 minus -30. Well, that becomes plus, so that's 0. 18 minus 16, well, that's 2. 2 minus 8, that's -6. So what do they all have in common? The difference of any 2 even integers is an even number. 2, 4, 6, 8, 10. Anything ending in 0, 2, 4, 6, 8. And they all end up that way. Positive or negative, they're even numbers. Find a counterexample to show that the conjecture is false. Draw a picture if necessary. An angle bisector always creates 2 acute angles. Well, you might think, well, let's see. Yeah, those are both acute. All right. And you could do that multiple times. Let's say even if you did a 90. Okay, 45, 45. But this is an angle right here. That's 180 degrees. And if I bisect it, I bisect it into 2 90-degree angles, which are not acute. So right here, I have my counterexample. Vertical angles are always complementary. Well, if I have this angle here and this angle here, and let's say they're both 30, well, 30 plus 30 is not 90. So there's a counterexample. Decide whether inductive or deductive reasoning is to be used. Explain. All right, so remember, inductive reasoning is when you use a pattern, and deductive reasoning is when you use already known, accepted definitions, facts, properties, the laws of nature, that kind of stuff. All right, so this weekend the sun was shining and it did not rain. So the next time the sun is shining, you know it will not rain. Now, can it rain when it's shining? Of course it can, but you're basing this on what you've already seen. So that is inductive reasoning. It's based on what you've seen. Or what you observed. Okay? The product of 2 integers is always even. So that's your statement of fact. Okay? Based on this, because 92 and 14 are even, the product is also even. That's deductive reasoning. It's based, excuse me, on a mathematical pattern or fact. All mammals have hair. Cats are mammals, so all cats have hair. Well, that's not true because there are hairless cats, but you're using deductive reasoning here based on biology. Right. Each time you walk to school, each time you go to school, you walk. You went to school today, therefore you must have walked. That is using inductive reasoning, again, based on a pattern. Okay. Moving on. All right, use inductive reasoning to write a formula for the perimeter of a regular polygon. Okay, regular means all equal sides, technically, and angles, with n number of sides, where each side is s units long. Okay, well, let's think about this. If we had a square, okay, a square has 4 sides, and if each side was 2, the perimeter is when you add up the sides. So that'd be 2 plus 2 plus 2 plus 2, which is 8. All right? But a shortcut to addition is multiplication. So, therefore, perimeter is equal to the number of a regular polygon is the number of sides times the side length. All right, so that's a shortcut. Sketch a diagram with a description. GH, line GH, intersecting XY, line XY, at point A in plane Q. So first off, I'm just going to start by drawing a line. And I'm going to draw an intersecting line. Okay? One of them is GH, so I simply put a G here and an H here. XY, they don't have to be on different sides. It can be like this. Okay? Intersecting at point A, so I have to make this point right here where they intersect, point A, in plane Q. All I do is kind of draw a parallelogram-ish shape around it and put a big old capital Q out here. ST, okay, well, that is a segment. So it has to be the endpoints here. Bisected. So bisected means I'm going to be cutting it right in half. So I'm going to put a mark right there. By UV, so it's going to be this line here, UV at point V, so this has to be V, U has to be just somewhere on this line, in plane R. Again, a boxy shape around it and put an R. That's it. All right. Planes L and K, use the diagram to determine whether you can assume the statement. So planes L, here's L, and K intersect at PS. Well, they intersect right here, and PS is there, so that's true. Points U, M, and O are coplanar. Well, let's look at that. Let's find U, M, and O. So here's U, which is on plane L, M, which is on plane L, and O, which is on PS, the intersecting line, which means O is actually on both planes. But by looking at this, U, M, and O are all on there, so that's true. All right, now it says QOP is a right angle. Well, QOP is right here. There is a right angle mark right there, so that's true. If that mark was not there, we could not assume it. MQ is in plane L. Well, here's MQ, right? So MQ, part of it lies on plane K, and plane K probably continues through, so it's on plane K. You know that by the dotted line here. But it is not going through L, okay? The point Q is on L, but the line does not lie in the plane. So that is false. And last but not least, PS, which is right here, and MQ intersect at point O. Well, that's that point right there, so that is true. And that's it. Good luck.